Well, good evening and welcome to Space Oddities. You join us today on our first anniversary programme, and happy birthday to us. And as you may notice, we are in a bit of a celebratory mood. So thank you for joining us tonight. If you're new here, we don't normally look like this. We just thought we'd have a bit of fun today because it is actually a year since Space Oddities started. And I don't know whether a year ago we thought we'd still be here in a year or what our plans were. But anyway, we are. So we'd like to thank, obviously, all of our viewers for supporting us during this difficult time, and we've had a lot of fun bringing the universe to you every week, and we hope that it continues for a long time. So thank you to our crowd who watch us. We are very grateful for your support. I have to say, as always, a big thank you to those of you who've been buying us coffees over at buymeacoffee.com. That is much appreciated, and we're very grateful. And obviously, a thank you to our sponsor, Rother Valley Optics, for supporting us in this venture. So it's been a bit of a crazy year, one way or another. And I'm joined tonight as part of the birthday celebrations by Roger and Michael and Rachel and Jonathan and Daz. And unfortunately, some of the others, well, all of the others, in fact, couldn't be with us tonight, but they may be dropping in at some point. So we may have some surprise visitors turn up later. So what do you think, guys? A year that's gone very quickly, hasn't it?
Yeah, it certainly has.
Yeah.
I can't believe it. Really,
it certainly is.
Yeah.
Where did the time go?
I mean, it's been a pleasure. It's been a pleasure working with everyone, I must admit.
Yeah.
Well,
and I just hope we can just carry on playing and just get bigger and better and bring the stars to everybody. So
yeah, agreed, Daz.
Absolutely. And it's been enormous fun working with everybody to produce what we do, and we have some ideas for changes and making things better and bigger in the future, which we're working on at the moment, and we will let you know the outcome of those in due course. So and of course we're shortly expecting our first Space Oddities baby, courtesy of Rachel. Who opted to do that for us.
That's lucky then.
Happy to be of service.
So Rachel, when's baby due?
He's due on the 15th of July, but I'm not sure if he'll be here before then. He's a bit of a chunky astro baby, so he might be coming a bit early.
Right. Yes, I hope he doesn't do a Chloe and turn up 2 weeks early, and
or do an SLS and be or do an SLS and be years behind schedule.
Yeah. So well, obviously we wish you the very best of luck for the coming weeks. And we can't wait to see the photos of our first Astro baby here on the Space Oddities.
Ian's asked the question, Andy.
9 months integration time.
Oh.
Yeah. Right. So Ian says, do you all know each other outside of the broadcast? Well, yes and no in some cases. But
I met Daz once.
Yeah,
was that enough?
That was enough.
Yeah. He didn't come back for his bike anyway.
Yeah.
Me and Roger have had many a meal and social, haven't we, Roger?
Absolutely.
Yeah.
Astro events.
Yeah, we sort of like occasionally bump into each other, if we shows, and I've popped over seen Andy in Spain. So
Daz had a week here in Spain, which was fantastic. Which we hope you're going to repeat this year, Daz.
Yeah, it was a lovely time.
Yeah.
Sorry.
We hope you're going to repeat this year.
Yeah. Hopefully, we got plans. We'll see what we can do.
Fantastic. But other than that, we don't know each other. Other than just as they said, really meeting at astronomical events. And
well, it's the perfect family. We don't fight.
Yeah, that's right. Absolutely.
So yeah, it's the perfect family. Yeah, we all get on. We don't end up scrapping. So yet.
Oh, by the way, before I forget, talking of Astro events, if anybody's attending the County Mayo Star Party in November in Ireland, I'll be speaking there. So it'd be lovely to see some of you if you're around. And Steve says I've now met Daz, Roger, Michael, and Simon and Keith from the past. So
Ooh.
my Steve.
Oh, past life was that? Past life
Yeah.
Mm-hmm.
in another reincarnation was it?
Yeah,
Because I met
Daz and Steve at
I met Michael and Steve at Whittington.
Yeah,
Yeah,
that's at Whittington,
it was
yeah.
that was a good event, good little event. Yeah.
and Dave and Peter.
It was nice, great. Yeah, Dave and Pete, of course.
Yeah.
Kath and
Mary.
everyone. So
Yeah.
Yeah,
Mary, yeah.
it's
And I've
more
met a
difficult.
few of the,
So,
the
yeah,
audience as well. We've got Kevin there. We've got a couple of others. Chris, I've met those in real life too.
Yeah,
I still haven't met Mary in person.
Or she'll get you.
No,
she'll
no,
give
no.
you a pencil and pen and ask you to do
I
some
know.
sketching like she did with me.
There's been 2 occasions where I hoped to, but I couldn't do it at the time.
no, I
That's
couldn't
the
do that.
thing
The
as
only-
well. It's been a year of some of the viewers logging in and every day, well, every Monday for an entire year as well. So that we've sort of got to know them along the way as well.
Yeah,
We know
Yeah.
about Lee and his dogging habits and
yeah. So thank you all for your kind messages. Right.
Yes, that's
Heidi
good.
wants to know, Rachel, what's the weirdest craving you've had so far being pregnant?
it's the worst. And it's literally just happened this week, which is weird she's asked because I haven't had any throughout at all. I've just been quite blasé. Not really fancied anything, but this week it is a real struggle, and I mean like a real internal battle. I want to get a sponge. I want to get a fresh, clean sponge. I want to soak it with water, cover it with like fruity Radox shower gel, and bite it. And this is like having a shower and trying to not stuff a sponge in your mouth is really hard when it's right there. And I'm like, it's not good. It's not good. It's not good. So I've not even had a proper food craving. That is
These are normal thoughts, really. Normal
It is a real
thoughts.
thing. The midwives do warn you if you have like cravings that are not edible, because some pregnant women like want to drink bleach and do things you really shouldn't. So they sort of like get in touch, but I'm handling my my craving. I've not done it yet, so I'm okay. Just lots of fruity, sugar-free waters, quenching the thirst of the Radox.
Yeah. I was just going to say, if you feel the urge, just ask Johnny to tape you to a chair or something, and until the craving
How do you
passes.
think she got like this in the first place?
Oh, no.
There's always one.
Anyway, let's move on. Can we do some
Moving
astronomy?
Heidi wants to know if she can actually press a like button somewhere to like us already. I don't know. Is there a like button
Yes,
in the
there
like
is.
tab on YouTube?
Underneath the actual YouTube.
Yeah.
Underneath the
Underneath the actual YouTube screen.
Yeah, underneath the video window in YouTube, Heidi, if you're watching on YouTube.
Unless you're watching on full screen.
I think she means
she
likes
wants to
people's
like the
comments.
comments.
Yeah, I don't think
like-
there is a like tab.
Yeah.
No.
The only way you can really do it is by clicking the smiley face icon underneath the messenger and just putting in a smiley face. That's the only way you can do it. You can't actually put something on the end of a message, unfortunately.
Yeah, absolutely.
But the way people go through here, that it's gone by the time you get a chance to like it.
No, absolutely.
And of course, Michael Dunn says after the year of this adventure, we are at the same point on our journey around the sun as we were this time last year.
Ooh.
That's very true.
That's very
theory.
deep.
Yeah.
Very philosophical. Yes.
It is.
So we're obviously in the same constellation.
Yeah. As seen from somewhere else. Yeah, absolutely.
From the sun.
From the sun. Yes, absolutely. Yeah. Thank you for that, Michael. That's very true. That is very true indeed. Okay, right then. So yes, we are a year old, but we're going to carry on tonight in the traditional way, which means I'm going to hand you over now for a look at the night sky to Roger.
Hey. Right then. Here we are then. And we're going through the end of May into the first week of June already. So we'll be getting to the shortest day later in about another month's time. So astronomical darkness will be back with us again soon, but not soon enough. So, unfortunately for us astrophotograpers, not only have we lost our darkness, but there's a full moon on Saturday as well. So that's not going to help at all, is it?
No.
But this is what the moon was like about an hour and a half ago. So if anyone wants to go and have a look, see what's what with the moon, that's what it's currently phased at.
I mean, an hour and a half plus the time it takes to get here.
And this was the sun today as well. And we've still got quite a few sunspots still lurking about. And that group down the bottom, 3315, has been rather energetic lately. So,
yeah.
But apparently there's another large sunspot coming around from behind. So this could be another interesting event coming on. So watch out, Mr. Carrington. And while I was imaging the other day, this is some of those spots that you've just previously seen. And this is what it looks like through the quark, with a few little flares in the area as well.
That's beautiful.
And
lovely, yeah.
And here's some flares from a few days ago. It's the same flare, but at different points of its timing. So there were some absolutely stunning ones when I was with Simon Holbeck with the Bath astronomers on Saturday in Bath. There was absolutely huge prominence coming out, and there's me stuck at Bath showing all these people, but they were quite appreciating to see such a huge prominence coming away from the sun, and that only lasted about 25 minutes from start to finish. So
wow,
it was rather awesome. But here we have in the night sky the start of the summer constellations. We've got the summer triangle of Vega, Deneb, and Altair. Now coming up, these are times at about 11 o'clock when it's sort of dark, but not properly. But as you can also see, we've got the Milky Way coming up through, and during the night you will see the Milky Way core coming up through with Scorpius as well. So things aren't looking too bad that way. And we've only really got Venus at the moment to lighten our evenings, of course with the moon as well, but some people don't bother with the moon, do they?
No.
No. But that's about all there is for the moment, I'm afraid. No new images from the web or anything like that, so I can't show you anything more, I'm afraid.
Okay, thank you very much, Roger. Fantastic. Okay. Talking of the James Webb Space Telescope, the James Webb Space Telescope has been making some observations of Saturn's moon Enceladus, interestingly, and it discovered something quite amazing this week. So without more ado, we're going to go over to the news, and I can tell you all about that. Just give me 1 second. Firstly, the Mars helicopter Ingenuity, there's a bit of a problem with it in as much as it's sort of missing in action. The reason for this is that over the last couple of flights, now don't forget the Martian helicopter Ingenuity was designed, they thought, to last about 5 flights. Its most recent flight was flight 51. So it's lasted a hell of a lot longer than anybody anticipated. But then, you know, we should have expected that really with the history of the Mars rovers Spirit and Opportunity, which lasted for years and years beyond their sort of expected lifetime. But the last couple of months, the rover Perseverance and the helicopter Ingenuity have been moving through some very varied and hilly terrain. And if you look at this image here, firstly, in the foreground, you can see a hill. and you can see the shadow of the helicopter on the hill. After this,
Andy, we got no images.
No.
well, that's very strange. Just give me 1 second. What's gone wrong there then? Okay, give me 1 second. Something has obviously gone wrong. Just I think I know what it is. Just give me a second, and
On and off at the mains.
yeah,
Go
I'll
on.
put that right for you. Right, can you see it now?
No.
Nothing
Not
at
at the
all.
moment.
Oh, that's very strange. Right, this should do it. There we are.
Yay.
That's got it.
Ah, there we go.
So, slight technical glitch there. Yeah, as I was saying, so in the foreground, you can see a hill, and you can see the shadow of the helicopter on the hill. This hill is obviously very extremely strewn with rubble and stones. After this flight, the helicopter landed at the base of this hill that you see in the foreground. It had no direct communication line of sight with the rover, so they couldn't communicate. Now, has not been a problem in the past. They've had a few periods where the rover and the helicopter have not been able to communicate because of the terrain. But this time it seems to be slightly more worrying, and they haven't had communication with the helicopter in a couple of weeks. This is compounded by the fact that the helicopter's solar panel is clogged with dust and is not able to generate the same amount of power as it used to be able to. So anyway, so the situation at the moment is that they're not overly worried. The rover is moving to try and sort of catch up with the helicopter so it can establish communication with it. And this is the video that the rover took. If you look at the top left of the screen, you can actually see the Perseverance rover, and there you are, very clear there, the Perseverance rover taken from the helicopter. This is not the helicopter moving, by the way. This is a still image that's being zoomed in on, just to show that how far apart the two actually are. It's about 700 meters, if I remember rightly. So they really need to re-establish communication with the helicopter before the power drops altogether because of the amount of dust on its solar panels. The same thing, of course, that killed the Martian InSight probe that NASA recently said goodbye to because of dust on the solar panels. There we are. So that's that. I was talking about the James Webb Space Telescope. It has spied a huge plume coming out of Enceladus. As we know, Enceladus has plumes of water vapor and ice and minerals being ejected from its south polar region from fissures in its crust nicknamed tiger stripes. And apparently Webb has seen a plume that is twice the diameter of Enceladus itself, the biggest plume ever discovered coming out of Enceladus. We know that a lot of material comes out of Enceladus. You may have seen me talk about this on Moon of the Week. I think it was the week before last. But anyway, this material actually goes towards making up Saturn's E-ring. So all this material actually forms one of the rings of Saturn. But this is the biggest plume ever seen. Now, try as I might, I haven't been able to find any actual images of this yet, nor an exact size for the plume. But it is apparently, as it says, it's being described as a monster plume. So hopefully next week we should have some actual images of this plume. These plumes have been shown to contain minerals that have been in contact with rock. So we're pretty sure that there's an underground ocean on Enceladus, and at the bottom of that there's a rocky ocean floor, and therefore there's a possibility that there could be life in that ocean. And one day we'll find out, I suppose. Moving on, an event's happened. The ESA Euclid telescope has arrived in Florida. It was sent by boat from Italy. It's a new telescope from the European Space Agency, which is going to explore the dark universe. What do I mean by the dark universe? It's specifically tasked to understand dark energy and dark matter. And the mission is going to last 5 years. The telescope will be based at L2, where the James Webb Space Telescope is stationed, of course, about 1 million miles from the Earth. And then after the mission is over, they reckon it's going to take 5 years to analyze the data before they can come up with any conclusions about what the data is telling them. So we could be looking at, towards the middle of the 2030s before we find out exactly what this telescope has found. Still quite a long way off, but that's the nature of the beast. The good thing is that the telescope has arrived safely in Florida. And the even better news is that it's launching in July, and you can watch it live with us on Space Oddities, because we certainly will be covering that. Hopefully it won't be at a ridiculous hour of the night, but we will do our very best to cover that. And that's about all I've got for you for the news this evening. So there we are.
Yeah, it's a bit of a shame about the Ingenuity news, because of the. Sorry, I'm looking at the wrong thing now. It had done 51. It was up to nearly 60. The last I saw, if it may have already gone over. So it'll be very sad if we lose it. But you've got to remember, it was only supposed to do 5 flights at the most.
Yeah, exactly.
They didn't even know if it would work. So this
No.
has been an absolutely amazing little helicopter. Or drone, or whatever people want to call it. It just keeps giving, and it'll be such a shame if we lose it now. But on the back for the engineers and the people who've been using this or have been flying this on Mars for the past year or so. So big round of applause for a little Ingenuity, I think.
JPL have done a fantastic job, because, as you said, nobody knew whether it would actually be possible to fly that little helicopter or any sort of vehicle like it in the extremely thin Martian atmosphere. Don't forget, the Martian atmosphere is only 1/100th the thickness of the Earth's atmosphere. So to get it moving at all in that immensely thin atmosphere was a triumph. And they have been using it to do reconnaissance work for the Perseverance rover, so that they could see in advance what type of landscape the rover was getting itself into. Because, of course, you can look at these things from orbit, but they don't give you the fine detail of being actually on the ground. And if perhaps the Martian exploration rover Spirit and Opportunity had a helicopter doing similar reconnaissance work, they might not have stumbled into sand dunes as they did from time to time and get stuck, which eventually, of course, will spell the death of both of them. So an amazing.
And of course, the technology on Ingenuity is going to be transferred to other drones in the future on other moons.
Absolutely, and don't forget, we've got that huge car-sized helicopter, Dragonfly down on Titan in the early 2030s. So we've got some really interesting times ahead for aerial vehicles on.
Back to Ingenuity, of course, it's going to be going back to Ingenuity. It's also going to be tied together with their little dogs that they set sometime put a lander in, and use Oppie to use Ingenuity to scout out, and then the little dogs will go off and explore lava caves and things like that, and then they'll come back to the mothership, or whatever you want to call it, and then they'll be recharged overnight. And again, there's the same sort of system as they're using with the British rover that's going to be landing on the moon with Peregrine. Eventually they'll be sending up several of these with a sort of like a mother type ship, and they'll go off, do all their stuff, come back and download all their data, and then be recharged at these things, then go off again the next day. So all this stuff that they're thinking about is fantastic.
Do we have a launch date for Peregrine yet?
It's in.
There is one chalked in, but of course it's the Vulcan, isn't it?
It's the Vulcan, isn't it?
And I'm not going to put any money on it going when it says. There is a date. I can look it up for you if you wish.
No, just kind of, because the other day that it was all in the news. Today is the the day for the Vulcan static fire, and after that I heard absolutely nothing. So I gather it didn't happen.
According to then it was the 4th of May, but they're conducting an investigation following a test article anomaly.
Yeah,
I think there's something about the 30th of May rings a bell about Vulcan, or the 30th of June, something like that. I'll just
yeah, but the other day they announced that they were static firing the Vulcan.
Right.
Yeah, I saw that. Yeah.
Seems to have happened. So don't know. Anyway, not to worry. Yes, it is a shame about the helicopter, but it's good news about Euclid that this telescope, which has been a long time in development, which promises to teach us so much about the dark universe, about dark energy and dark matter, is finally launching in July. So that's been a little while coming, but a long while coming. But it should reveal some hopefully amazing facts about the dark universe, the things that we really don't understand, dark energy and dark matter. But as I said, they reckon it's going to take them 5 years to analyze the data, having surveyed the sky. And, we could all be a lot older before we find out exactly what the telescopes found. So there you are. Okay, well, let's move on. Now, it's as you know, we started a new feature a few weeks ago here on Space Oddities called Moon of the Week. Well, we're going to carry on with that now. But in fact, this week it's Moons of the Week, plural. So I'll let Daz talk you through this week's edition of Moon of the Week.
Yeah, this week I'm going to spoil you. You're going to have 2 moons, and they're the moons of Mars, Phobos and Deimos, and they're 2 very strange little moonlets. As you can see, they're not round; they're not big enough to form a spherical planet or moon, and that we know not that much about them because Phobos, which is the bigger one, actually orbits closer to Mars than Phobos, the little one. Well, what I'll do anyway, what we'll do is I'll do a quick few bullet points, and then we'll get into the nitty gritty about these little planetoid things. Right, here we go. There are 2 moons of Mars. They are Phobos and Deimos. They are not the traditional round-shaped moons we often see, but are very irregular in shape. Both were discovered by American, now I may get this name wrong, but it's Asaph Hall in 1877, and are named after the Greek mythical twin characters, Phobos, which means fear and panic, and Deimos, terror and dread, who accompanied their father Ares into battle. Now, Ares was the Greek god of war, but was known to the Romans as Mars. Compared to the Earth's moon, the moons Phobos and Deimos are small. Phobos has a diameter of 22.2 kilometers, which is 13.8 miles, while Deimos measures 12.6 kilometers, which is 7.8 miles across. Phobos, the larger of the 2, orbits closer to Mars at 9,377 kilometers, which is 5,887 miles, with an orbit period of 7.66 hours, while Deimos orbits further out at 23,460 kilometers, which is 14.580 miles, and an orbit period of 30 to 35 hours, 30.35 hours. Now, before we get into the actual more specifics about them, before they were actually discovered, speculation did exist about the moons of Mars, which began when the moons of Jupiter were discovered, of course, by Galileo, and also when Galileo Galilei believed he had possibly found 2 moons around Saturn. Now, Galileo had to make his report in a code due to the situation at the time regards the Catholic Church, and so he put his report in a hidden in a code. And what he did is he took the 4 words which in Latin, which actually said, and I'm not going to try the Latin, please don't even ask me.
Go on, do it.
I have observed the don't. I have observed the most distant planet to have a triple form. Because he noticed 2 bumps on either side of Saturn. To disguise this, he mixed up all the letters and made a massive anagram, which I'm not going to try and repeat. Now, Johannes Kepler, in trying to decipher the anagram, misinterpreted the meaning to have read, "Hello, furious twins, sons of Mars." So he believed Galileo was referring to Mars. Perhaps inspired by Galileo's work and quoting Kepler's work and quoting Kepler's third law of planetary motion, Jonathan Swift, the writer of Gulliver's Travels in 1726, refers to Mars having 2 moons in Chapter 3, Voyage of Laputa, in which Laputa's astronomers are described as having discovered 2 satellites of Mars orbiting at distances of 3 and 5 Martian diameters, with periods of 10 and 21.5 hours. Phobos and Deimos, as I said, were both found in 1877, more than 150 years after Swift's novel. And they actually have orbital distances of 1.4 and 3.5 Martian diameters, and their respective orbit periods are 7.66 hours and 30.35 hours. So, in theory, wasn't that far off. In the 20th century, V.G. Perminov, a spacecraft designer of early Soviet Mars and Venus spacecraft, speculated Swift found and deciphered records that Martians had left on Earth. I think there's a bit too much vodka involved in that. However, the view of most astronomers is that Swift was simply employing a common argument of the time, and that was, as the inner planets Venus and Mercury had no satellites, Earth had 1 and Jupiter had 4. Of course, that was all that was known at the time. So by analogy, Mars should have 2. Furthermore, as they had not yet been discovered, it was reasoned that they must be small and close to Mars. This would lead Swift to make a rough, accurate estimate of their orbital distance and revolution periods. In addition, Swift could have been helped in his calculations by his friend, the mathematician John Arthurnot. Also, Voltaire's 1752 short story Micromeges, which was about an alien visitor to Earth, also refers to 2 moons of Mars. Voltaire was probably influenced by Swift. In recognition of these predictions, 2 craters on Deimos are named Swift and Voltaire, while on Phobos there is one named Reggio or Laputa Reggio, and one named Planitia or Lagado Planitia, both of which are named after places in Gulliver's Travels, one being the fictional Laputa, a flying island, and Lagado, the imaginary capital of the fictional national Balabardi. Many of the craters on Phobos are also named after characters in Gulliver's Travel. So let's talk about the discovery of them. As I said, Asaph Hall discovered Deimos on the 12th of August, 1877, and Phobos on the 18th of August, 1877, at the U.S. Naval Observatory at Foggy Bottom, no jokes, in Washington, D.C. At the time, he was deliberately searching for Martian moons, so it wasn't just a lucky hit. He was actually looking for them. Hall had previously seen what appeared to be a Martian moon on the 10th of August, but due to bad weather, he could not definitely identify them until later. The telescope used for the discovery was the 26-inch or 66 centimeter refractor telescope, then located at Foggy Bottom. In 1893, the lens was remounted and put in a new home where it remains to this day. The names originally were presented by, respectively, were suggested by Henry Madan, the science master of Eton, and he took his inspiration from the names from the Book 15 of the Iliad, where Ares summons fear and fright. In 1959, Walter Scott Houston perpetrated a celebrated April Fool's hoax in the April edition of the Great Plains Observer, claiming that Dr. Arthur Hale of the University of the Sierras reported that the moons of Mars are actually artificial satellites. Both Dr. Hale and the University of Sierras were fictional. But this hoax gained worldwide reputation when Houston's claim was repeated in earnest by a Soviet scientist, Izov Shklovsky, who, based on a later disproven density estimate, suggested Phobos was a hollow metal shell. Surveys or searches have been conducted for additional satellites or moons. In 2003, Scott S. Shepard and David C. Jewett surveyed nearly the entire area around Mars for irregular satellites. However, scattered light from Mars prevented them from searching the inner few arc minutes where the satellites Phobos and Deimos reside. So basically, Mars was hiding. If there was any more moons to be found, they were hidden in its glare. Now, a little bit of technical stuff. I'm not going to go into too much, but Phobos dimensions of 27 kilometer times 22 kilometers times 18 kilometer, and retains too little mass to be rounded under its own gravity. So this is why these moons are not round like our moon. Likewise, Phobos does not have an atmosphere due to its low mass and low gravity. It is one of the less reflective bodies in the solar system, with an albedo about 0.071. The albedo being how much light is reflected by the surface of an object. The darker the surface material, less reflection. The brighter the surface material, more reflection. To compare, our moon has an albedo rating of 0.12. The Earth 0.30 and Mars 0.16, with a rating of 1.0 being total reflection, 100% reflection. So you're talking about percentages here, really. Infrared spectra shows that Phobos, that it has a carbon-rich material found in carbonaceous chondrites, and its composition shows similarities to that of the Mars surface. So you've got Phobos density is too low to be solid rock, and it is known to have significant porosity. These results led to the suggestion that Phobos might contain a substantial reservoir of ice. But further spectral observations indicate that the surface regolith layers lack hydration, but ice below the regolith is not ruled out. Deimos, however, unlike Deimos, Phobos, heavily cratered, with one of the craters near the equator having one of the craters near the equator having a central peak despite the moon's small size. The most prominent of these is the crater Stickney. Now, when you see Phobos, the picture that's actually on there now, you can see this massive crater, and there's even a smaller crater inside, which again is named after a character from Gulliver's Travels. And this is named after the wife of Asphalt Hall, the discoverer of Phobos. It is a large impact crater, some 9 kilometers or 5.6 miles in diameter, which takes up a substantial portion of the moon's surface area. As the Jupiter's moon Mimas crater, Mimas's Herschel crater, The impact that created Stickney must have nearly shattered Phobos. Many grooves and streak, which you can see on the image now, emanate from the crater, and over the oddly shaped surface. The grooves are typically less than 30 meters or 98 feet deep, up to 100 to 200 meters or 300 to 660 feet wide. So they're quite big things, and up to 20 kilometers, 12 miles in length. And they go down the lateral length of the actual moon. You can see them here.
Yeah, you can see that. You can see them here, going sort of halfway across, right from.
Yeah,
it's and I think they've recently come to the conclusion these rifts are being caused by the gravity of Mars as it pulls Phobos ever closer.
Yeah, well, if you look closely, you'll also see lines of craters all in one long line. Now, these are called cantinas on the moon. You find them on the moon, you find them on Earth, you find them on other planets, and it's usually where a whole usually a larger object is broken up and then hits the object and forms this line. Now, I've lost my place now. And these grooves. They were originally assumed to have been left by the same impact that created Stickney. Analysis of results from Mars Express spacecraft, however, revealed that the grooves are not in fact radial to Stickney, but are centered on the leading apex of Phobos in its orbit, which is not far from Stickney. So this is the leading edge. As it's orbiting around, this is the leading edge that's that you're actually looking at. Sorry, I've just moved me. Spacecraft revealed that the grooves were not in fact radial to Stickney, but are centered on the leading edge of the area. Researchers suspect that they have been excavated by material ejected into space by impacts on the surface of Mars. The grooves thus formed as a crater chain, as I was talking about, and all of them fade as the trailing apex of Phobos is approached. So as it moves back, they fade away. They have been grouped into 12 or more families of varying age, presumably representing at least 12 Martian impact events. So what they're saying is that because of the thin atmosphere of Mars, and also that Phobos actually orbits, which we'll talk about in a second, so close to the surface that when big impacts have happened on Mars, it's thrown the ejector up into space, and Phobos has passed through it, causing these craters to form and also these grooves. But it's not everybody agrees with it. However, in November 2018, following further computational probability analysis, astronomers concluded that the many grooves on the Phobos were created by boulders ejected from the asteroid impacts that created Stickney crater. These boulders rolled in a predictable pattern on the surface of the moon. So they're saying the boulders thrown backwards from this impact caused it. The unique Cadium meteorite that fell on a Soviet military base in Yemen in 1980 has been hypothesized to be a piece of Phobos, but this has been difficult to verify because little is known about the exact composition of Phobos.
I mean, you've got to remember, Phobos would make an excellent staging post for any Mars missions. And it's been seriously suggested that what we should do, rather than go directly from the Earth to Mars, is to set up a base on Phobos and descend to Mars from there, because it would make things a hell of a lot easier than going directly from the Earth to Mars, because you could put fuel depots on Phobos. You could build a really useful infrastructure to set up travel between Earth and Mars. If you use Phobos as a sort of a staging post. So, there is that.
Yeah. Basically, and just to show how small it is, a person who weighs 68 kilogram force or 150 pounds on Earth would weigh about 40 grams force, which is 2 ounces, standing on the surface of Phobos. Like most bodies of its size, Deimos is highly non-spherical, with triaxial dimensions. That's the overall dimensions. If you form a cross and then put a spike through it to give you the rough axes. The 15 times 12.2 times 11 kilometers, making it 56% the size of Phobos. Deimos is composed of rock rich in carbonaceous material like C-type asteroids and carbonaceous chondrite meteorites. It is cratered, but the surface is notably smoother than that of Phobos, and as you can see it in the picture here, it looks almost like a bit of a peach.
Yeah.
And this is caused by partial filling of the craters with regolith. The regolith is highly porous and has radar estimate density of 1.4 per centimeter cubed. Escape velocity from Deimos, this will be fun, is 5.6 meters per second. This velocity could theoretically be achieved by a human performing a vertical jump. So so you could jump off of it and just float off into space. And the apparent magnitude is 12.45, which means it's very, very dim.
Yeah.
Yes, Andy.
Yeah. Okay, no, I was going to say that I remember an old Asimov science fiction story. I think it was set on Deimos. It was certainly set on a moon or an asteroid like that, where you could literally just jump off and put yourself into orbit around the body just by an energetic jump. So, but if you remember when the space probe Philae tried to land on Comet 67P, and bounced, it was still traveling at 1 meter per second relative to the comet, and they still couldn't get a hold on it because the
bounced on it.
The gravity was so weak. So definitely.
We'll just talk about the orbital characteristics now. Phobos has the lowest orbit to its host body than any other moon in the solar system. If viewed from Mars' surface near the equator, a full Phobos moon looks about 1/3 as big as a full moon on Earth. And of course, it only looks that big because it's a lot closer.
Yeah.
Due to its close orbit, it would look smaller when the observer is further away from the Martian equator and falls below the horizon the further north or south you go, and thus cannot be seen from the Mars polar ice caps. Deimos looks like a bright star or planet for an observer on Mars, only slightly bigger than Venus looks from Earth. Of course, there are no total eclipses on Mars because they're so small, and they never completely cover the sun. On the other hand, lunar eclipses happen virtually every night. The motions of Phobos and Deimos would appear very different from that of Earth's moon. If you were stood on Mars, Phobos, being within the synchronous orbit boundary, has an orbit that is very, very fast. A synchronous orbit is an orbit in which the orbiting object in this case the moon, takes the same amount of time to complete an orbit as it takes the host object that it is orbiting, like Mars, to rotate. Because Phobos travels so fast, it rises in the west and sets in the east, which is totally different from what we're used to, and rises again in just 11 hours, so it can be seen twice a day. While Deimos, being only just outside the synchronous orbit, rises as expected in the east, but very slowly. Despite its 30-hour orbit, it takes 2.7 days to set in the west, as it slowly falls behind the rotation of Mars. So it's moving slower than rotation. Both moons are tidally locked, always presenting the same face towards Mars. Since Phobos orbits Mars faster than the planet itself rotates, tidal forces are slowly but steadily decreasing its orbital radius. At some time in the future, when it falls within the Roche limit, Phobos will be broken up, and these tidal forces by these total forces and either crash into Mars or form a ring around the planet. Several strings of craters on the Martian surface, inclined further from the equator, are inclined further from the equator the older they are, which suggests that there may have been many other small moons that suffered the fate expected of Phobos, and that the Martian crust as a whole has shifted between these events. Deimos, on the other hand, is far enough away that its orbit is slowly being boosted, so it's getting a gravitational assist in a way, akin to Earth's moon, and will eventually be ejected away. Now, there is a lot of contention as regards their origin. Now, we've got one of the is that they're captured asteroids from the asteroid belt, and their density, basically their spectra, albedo, and density, and of course their carbonation C-type asteroids, and these are all found in the asteroid belt. Based on their similarity, one hypothesis is that the moons may have been captured main asteroid belts, as I just said. Both moons have very circular orbits, and it would take a lot to actually be able to catch these moons and put them into a circular orbit, basically around the equator, because they would come in at some rate of knots. They'd have to be slowed down by the atmosphere and then adjusted tidally by gravity forces to put them in this orbit around Mars's equator. So some people sort of like frown upon this idea that they're actually captured asteroids. There's also a possibility that some people think that Phobos could be a second-generation solar system object that coalesced in orbit after Mars formed, rather than forming concurrently at the same time of the birth of the Mars cloud. And what they're saying is basically that there was probably a bigger moon that could have been hit by a larger object, which absolutely destroyed it. And then this would form these two smaller moons at a far distant orbits around the thing, but then they got separated, and Phobos moved towards the center. There are lots of, there's also one which is sort of like Mars's Gaia moment, where a large object actually hit Mars, throwing up ejecta, like with Gaia, with our moon, formed a debris ring from which a large moon formed, which then was gravitationally ripped apart or hit by another object later on, and then the two smaller moons were formed out of this debris disk. And there's also one where they think that maybe they could be again asteroids that were caught, but for the two of them, they would have had to have been in a twin system, and then they were removed when they were caught by Mars's gravitation. I'm not going to go into it too much because there are lots and lots of things that they're looking at. They're even doing computer simulations to try and sort out why they think that they formed. But some of them, they just haven't been there long enough for what they're trying to explain happened. Now, there have been past attempts to go to Phobos and Deimos by the Russians, by NASA, by the Europeans, the Russians did try. They flew 2 missions in 1988. One of them failed completely. The second one did actually capture some photographs, and they were supposed to be sort of like jump landings in which they were going to collect some samples and return them.
When they called Phobos 1 and Phobos 2, if I remember rightly, and I think the second one they established that both the main computer and the backup computer had failed, and that actually the spacecraft had actually bounced off Phobos, so it did get to Phobos, it just bounced off. And was lost. Yeah. So there we are. Right, guys.
In the 1990s, in the 1990s, the Americans had a go. Were thinking about it with a mission called Aladdin. But the only current proposal that is actually, there are a couple ideas that NASA are playing with. the other current proposal, the only proposal at the moment, is from the Japanese, and they are hoping to take a Martian Moon Explorer (MMX) to the moons in 2024, which they will return samples
Right.
from Phobos. So I'll leave it at
Thank
that.
you very much, Daz. That's great. I just want to show you one image taken from the surface of Mars, which is an eclipse of the sun by Phobos. This was taken by, I think, the Curiosity rover. And there you are. Now, as you said, they're too small to form total eclipses. But here's a partial eclipse of the sun by Phobos, taken from the surface of Mars. You can see the sun, incidentally, sunspots on the sun there very clearly as well in that image.
Yeah, exactly.
So,
glare away.
I love that. Yeah. So just imagine you're looking at an eclipse of the sun by a moon of an alien world, which is just absolutely amazing. I'll show you that because I do love that image. We do say at this point a warm welcome to Bernard, who's joined us for our birthday celebrations. So how are you, Bernard?
I'm doing fine. I'm terribly sorry I've arrived late, but better late than never, as they say.
Yeah, absolutely.
Yeah, and happy anniversary to the show.
Yeah, happy anniversary to everybody. It's been a blast the last year. It really has. Sorry, Michael?
No, Daz has disappeared.
Oh, yeah. Well, this happens with Daz. Somebody arrives and Daz disappears. He's not stormed out in a huff, but he's still got bandwidth problems with his internet connection. There we are. He's reappeared.
I might have kicked him out. I don't know,
yeah,
but he's back.
Don't worry, no problem. All right, now let's move over now. Rachel, I can't see the gallery loaded.
I think it's because it kicked me out earlier. So let me.
Right, okay, all right. We're going to move on to Rachel now, and thank you very much, viewers, for sending in your gallery images as ever. We do love looking at them. Rachel wasn't with us last week, so we've got a little bit of a backlog. But anyway, thank you. And if you would like to send us your images to appear in the gallery, mail them to spaceodditieslive@gmail.com. One image per email, please, which will make it a lot easier for Rachel to sort things out. And there you are. spaceodditieslive@gmail.com is the address. We do love seeing your images, as I always say, so do share them with us. So what have we got this week, Rachel?
We've got a big gallery this week with all sorts in. So we're starting off with Lee, who sent in a nice wide field of the summer triangle. He said he's been busy and stressed lately, so he's not done a lot of work, but he's managed to capture the Milky Way from Cornwall. And it's a new site that he's testing out with his DSLR as well.
Fantastic.
So he says it's not the best, but Lee always says this and always sends in lovely images. So
that's fantastic. Thanks, Lee. It's good to see the summer triangle again, isn't it? It really is.
I think we all need to have a holiday, a Space Oddities holiday to Cornwall.
Yes, definitely. I love Cornwall.
Oh, but did it say
Thank you, Lee.
that they were only 3 3-second images? Did I read that right?
He said it is the 10 sets of 13-second stacked.
Oh, 13, sorry. Okay.
Yeah.
Nice and dark then.
So, yeah.
Yeah.
Yeah, very nice. Lots of nice red colour as well in there, which is not always easy to pick up.
Yeah, that's right.
And we'll go on by Daz. Daz, do you want to talk us through?
Oh, well, I don't know. Which one did I send you? Oh, yeah, this was the International Space Station, because Andy was talking about that he'd like to see some nightscapes in there. And this is, and as you can see, this is the actual International Space Station. It had already passed over. There was a whole series of photographs, but I thought I'd pop this one in because even though it's full of light pollution, it actually gives it some atmospheric feel about it.
Yeah.
You've got the ISS that is going into the light pollution of Shrewsbury. You can see it was hazy cloud. You can see the clouds up top, but also you can see that the street lamp, because it was that time of night, they hadn't gone off, was actually casting some colour into the trees. And it just sort of like gives it that little bit of oomph, something else to look at. You haven't just got a silhouette. And this is just using, you can see the details there, it's just using a standard SLR. And the length of time was to basically try and capture the movement of the ISS. As I said, there was a whole series of them catching it from the west, because it was going from west to east. But as I said, it gives you color. There is also a technique where you can called light painting, where you use a torch and then you just shine it on the trees for a few seconds, and it brings all the colors of the trees out. So, but it's just gives some people idea of what they can do just with a standard camera without messing about. So that was a one shot. That was no messing about.
Can I just add something to that? A few nights ago, I was fortunate enough to see the ISS in daylight.
Really?
Yeah, it actually made a very bright daylight pass a few nights ago. I only found out about it minutes before it happened, so I wasn't set up, unfortunately. So
Wow.
Yeah, and of course it was only about a week later on here that I also called the International Space Station, and then about 15-20 minutes later we had the going across Axiom capsule, which was chasing the space station, which was quite an exciting little time. But I think Roger covered that last week.
Yeah. Yeah, right.
Yeah. Oh, well, thank you, Daz.
Thanks, Daz.
Then we've got a really lovely sun halo from Sonia. She said it's the most amazing one she's ever seen. But yeah, she's took this from Stockport and using her Google Pixel smartphone. And she used just her Google Photo app to tweak and edit.
That's lovely. That is a very impressive sun halo.
That's lovely, yeah.
It's really lovely.
I think what works really well with this picture is the foreground with the trees. It gives really nice sense of it sort of gives a nice composition to the
even that
picture.
low band of cloud as well. It just sort of all adds to it.
And
so
even
really
the vapor trails give a sense of perspective as well.
Yeah, it's a very impressive sun halo. I seem to have missed all the nice atmospherics in Doncaster. I don't know what was going on. Then we've got one by Martin, who I know is watching tonight. He captured the supernova in the pinwheel.
Well done, Martin. Fantastic.
Well done.
So he's also sent one side by side. So we've got the supernova visible on the left, and then obviously on the right you can see it is not. So we've got a nice little side by side comparison there.
Lovely, great.
It's a really bright supernova as well. Brightest one of the decade, definitely.
Yeah, but wasn't there also another one captured? Oh, sorry.
No, I was just saying, I think this picture got picked up by one of the magazines as well, maybe, or tweeted by something. So well done, Martin.
Well done, Martin.
Wasn't there another a supernova captured in a two galaxies that were interacting that I saw appear about a week ago?
Daz, I think in total there were three, apparently.
Really?
Oh, okay. Oh, I missed one.
Unless it's already twice.
Wow.
Supernova season.
Forget the clouds, so we're moving on.
Yeah.
Wow. So thank you, Martin.
Very good.
We've got Bode's Galaxy in a major by Jerry. Which again, it's a really haunting, spooky blue colour.
God, that is. That's amazing, Jerry. Really nice.
It's like a real vortex, doesn't it?
Yeah, it does.
Which is, really nice. And then we've got another blue by Chris, which is the Horsehead in a different light. So he rummaged through some old data and had a tweak and played around and made a wintry palette. And it's about 5 hours
that's fantastic.
of integration, which over half of it he said is in hydrogen alpha. So yeah.
Wow. That's
right, amazing.
That's amazing.
Beautiful. Thank you, Chris. We've got the sun by Kev.
Nice one, Kev.
This is a 12 panel mosaic, so huge. I don't ask what the
But look at all that action.
combined data gig is on that image, but a lot I can imagine.
Yeah, all that action going on.
So yeah, he said obviously top left is where there's been a lot of heavy action going on. He said this week, but I can't remember if it's from the week before. Because remember, I've got like a combined gallery, so the information might be slightly out. Because obviously, if somebody said they've imaged it this week, but I didn't pick it up till a week later, but still a really nice image. Then we've got another supernova by Kev again. So he turned his scope away from the sun for a brief moment in time and captured the supernova, which again they've kindly labelled for us over there.
That's beautiful. Look at that.
Wow.
That's only an hour and a half of integration as well, which is a lot of colour and detail for that.
Yeah. Well done.
Thank you, Kev. Everybody's been really busy, haven't they? Kev again, he went back to the sun. Look, you know where he wanted to be. And he's been doing the active region again, churning out some high energy flares and a nice pretty prom to go with it.
Yeah, I think he was an Aztec in the past life.
Just makes the sun look so furry and soft.
Mayan, I think.
Yeah.
So beautiful. Then we got one by Graham, which is the moon, which he took using his mobile phone and put it on his dob. So nice and simple and a cheap and easy way to get the moon, he says, which is
that's
what we all
great.
like.
It just goes to show what you can do with expensive equipment.
Yep. Still takes, you still got to find it and frame it, so don't take away all of the, the effort from yourself. But I mean, it does show that you can do things a lot quicker and cheaper than people think, which is nice.
Yeah, because I know Kath and Sonia do a lot with their phones, with their Dobsonian. So
So
excellent results.
Yeah, very nice indeed.
Then we've got a nice little cheeky glob in Hercules by Jerry, which he's trying out a new telescope. So he's obviously enjoying playing around with that. Look at the little diffraction spikes as well.
Very nice.
Oh, M13. Yeah, I see. Yeah. There's a message on their way to
that.
Very nice.
Then we've got the Arc of the Milky Way by Lee. So he's tried to do a panorama with this one. And you'll see on the full image, it's quite a wide image. So he says it's on near a slate quarry and a disused railway line. So listening to residents arguing and foxes courting and hedgehogs courting, and his only company was a pussycat that was hunting the local vermin. I think we enjoy Lee's stories as much as we enjoy the image.
Wow.
But yeah,
very nice.
Which part of the UK was this?
Look at that. Oh,
this is in Cornwall.
Cornwall.
So,
wow.
Beautiful.
As I've said before, the clearest skies I've ever seen have been from Cornwall. Unbelievable. When there's no light, it's amazing.
And I believe that wraps up our gallery for the week.
Great.
Oh, it's fantastic. A lovely gallery. That was really nice.
We had all sorts going on.
Yeah. Thank you, Rachel. And don't forget, as I said, if you want to send us your images, because we do love seeing them, then do email them in to spaceodditieslive@gmail.com, which is our general email address. And if you can, if it's convenient for you, one entry per email, please. Thank you very much. Okay, so Bernard, do you have any thoughts about a year of Space Oddities we were talking about earlier?
Oh, no, I'm just it's been great. I tried to watch this. I tried to stream it earlier when I was finalizing things I had to do when I came back home, and one of the questions was, do we know each other outside of the outside of the show. And actually, I don't really know anyone. I met Lou a few weeks ago in London, and that's it. So,
Yeah.
so in terms of my best memories about this 1 year anniversary is just to get everyone here on the stream and just getting to know all the folks, and it's just been great. So yeah, I think it's just the people that I remember the most. The people and the launches. Let's put it in that way.
The people and the launches. Well, we've certainly got some launches coming up in the near future that we're going to be covering.
Yeah.
Euclid, that I mentioned it earlier, that's going to be the big launch in July. That's going to be fascinating. So we wish you the very best of luck. I presume that's going to be on an Ariane.
It's on a Falcon 9, Andy.
Is it on a Falcon? Interesting. Because they're coming to the end of the Arianes, aren't they? I don't know how many they've got left. Only one.
Yeah, there's one. I think there's one more launch. I think there's one more launch, which hopefully we can cover.
Yes, one more Ariane 5.
Right. Oh, interesting. Be sad to see the old Ariane 5 go, because it's been an incredibly reliable launcher for Europe.
Yeah.
It did have a few teething troubles, like any new rocket does, but it has been an amazing success ever since.
Yeah, exactly.
And there we are. Okay.
Falcon 9.
Falcon 9. Okay, well, we'll look forward to that in July. I don't think we have a precise date yet in July, but we will keep you posted on that and let you know when we're going to do our coverage, which we hope to, if it's not sort of 4 o'clock in the morning or something. Because believe it or not, we do need our beauty sleep, as you can probably see from most of us. So there we are. And talking of a man who needs more than his fair share of beauty sleep, I'd like to hand you over to Jonathan now to do his regular Neo watch. So what's been going on, Jonathan?
Good evening, one and all. First and foremost, I know it's our birthday, but it's also the birthday of the European Space Agency's NEO Coordination Centre. They turned 10 years old on the 22nd of May. Now, at the time the NEO Coordination Centre was inaugurated, slightly less than 10,000 NEOs had already been discovered, and in the 10 years they've been in operation, there have been twice as many discoveries as in the previous 100 years. So that's testimony to their success, racking up that
was
sort of
money
number.
well spent then.
It was indeed, wasn't it?
Yeah.
They didn't have to keep the receipt with that one. An update on a story I covered a few weeks ago about the United Arab Emirates and their very bold plan to send a probe to an asteroid. Now, there's new news has been released this week, so they're obviously it's obviously been churning over in the United Arab Emirates that this is something that won't go away and that they're actually going to go ahead and do it. Although in my opinion, there still remains quite a few stumbling blocks in the way. Now, the UAE hope to dispatch a probe. It's named the M for Mother, B for Bertie, R for Rover Explorer, which on arrival at an asteroid named just this year will place a lander on its surface. They're still hoping to get something there by 2034, but the Explorer itself will pass 6 other asteroids en route, all differing in composition. So they're going to do a massive study of nearly 7 types of different asteroids just this year, offering the best possible landing site. And so it's good luck to them, but it's back in the news, so it's obviously something of massive consideration from the United Arab Emirates. Now, we were talking about, or we have been over the past year, about how we are going to evolve with regards to our onward. I mean, this is off the record, and this is my opinion, not possibly that of Space Oddities, but it looks like we're taking a step closer to the potential mining of asteroids. It's been the talk and of quite some time that this is going to happen. Still a long way to go. Of course, we've got to plunder the moon's resources first, after we've drained Earth dry. But there's another matter, of course, and that of Mars, what we're going to do with that. But anyhow, the French, have come up with a database of targets, of asteroids to target, should the day arrive to start mining asteroids. And I suppose when you look at fossil fuels and the move to wind turbines, and sadly, something that sort of didn't come to fruition, which was the enhancing of waves, 7S3, perfect for that, never happened. Well, the French have come up with a database of asteroids to target should the day of potential mining come around. It's a French team of scientists. They use data directly from the Jet Propulsion Laboratory's Small Body Database, which tracks almost 25,000 near-Earth objects, the asteroids most likely to be visited by a first asteroid mining mission. However, to date, and a bit of a drawback, there's only 326 of those 25,000 asteroids have yet been spectrally characterized, which means that they don't know the composition of which. So there's only 326, and I doubt just a small proportion of those are going to be a target. The system isn't even online yet for the French, so they haven't even got that up and running. It's a bold project, but I think it's they're just putting something out there in the interim to say that this is what we could do in the future. But a lot of work has to be done to determine exactly which asteroids are worth visiting, the cost, the efficiency levels of it, what they can mine from it. So, but anyway, 2 organizations in France have got together to generate this. As I say, it's not online as of yet, and there's still a lot of work to be done to discover exactly what asteroids are worth visiting. It's been 2 weeks since we looked at the current total of near-Earth asteroids, and they currently stand at 32,088. Of those, 1,488 remain in the risk list. And thanks to the work of the ESA and their big 10th anniversary, today, as it stands, we now know the good orbital information of 1,179,334 asteroids. So it really is, I know we're celebrating our birthday, but testimony to the ESA that they've come up and managed to do such good work to keep us all informed about the asteroids that we know of, that we are continuing to discover and continuing to plot and chart and keep a track on, which is oh so important. And that is that from the NeoWatch desk.
Chris says, what is the purpose of NEO? Is it merely to discover? In terms of intervention, we often don't see these things till they're sold past.
Exactly. It is to keep track, and I think I put a little caveat in every week that the ones that are going to catch us out are the ones that come either from sunward direction, which will catch us that way. But the more we can find out about the certain paths of things, it also gives us information about the likely paths of others. So it's information built on information. And yes, I'm afraid to say, still at this particular moment in time, the ones that we're still being passed on probably a 48-hour basis by very small rocks that we see very late on in the day. So as it stands at the moment, even though we have this massive database, there's still very little we can do about it, and we're still miles behind planning any interaction to actually deal with a threat. So yeah, it's nice to have all this information, but they really have to get to the stage where something firm is on the table, something tangible and that we can cost on the table to actually deal with it. So yeah, it's more of a library of information, but it's those ones that are going to come straight at us that we won't be able to deal with. But we must be prepared, and we're simply not there at the moment.
No, absolutely.
I don't know. I'm quite surprised. I have 2 words for you on that one.
What's that?
Bruce
Not
Willis.
Bruce Willis.
I managed to plug it in. Yay!
Yeah.
He's going to save us, right?
Oh, we forgot. Good old Bruce.
Welcome
out.
I gotta say, you said we missed him.
Yeah. Say good night to Bernard, everybody.
Yeah.
No, you're quite right.
Let
there,
that be a
Bernard.
warning to
we
you.
need the likes of Bruce to dig us out. It's just impossible without him. It really is. Thank you, Hollywood.
Yeah, absolutely.
Yeah.
Where would we be? Yes. Right, Jonathan, thank you so much for that, as always. Always never less than interesting. Thank you so much. And we'll look forward to next week's edition of NeoWatch. And that, I think, just about wraps up the programme for today, our first anniversary programme. We wish, viewers, you could be here to share a rather large cake with us, even if it's covered in shower gel. Thank you very much for watching the show today. And we do appreciate the coffees that some of you bought us, as ever. And of course, we do appreciate the support of Royal Valley Optics, who support us in our venture. So we reached the first year. What we'd like to see for the second year is a big expansion of Space Oddities. We need your help for that, though, in some small extent. Just tell everybody you know about us. Subscribe to the channel if you haven't done so already. Like the video if you haven't done that. All of that helps the YouTube algorithm take more notice of us, and helps us to do what we want to do. And we're just going to carry on bringing the universe to you, because that's why we're here. And we'll be here every week doing exactly that. We have got some space launches coming up this summer, which we will be following. We don't cover every space launch, of course, because just this week, as Daz and I were saying earlier, there have been launches all around the world, and the actual rate of space launches every week is accelerating dramatically, and we can't cover them all. But we will cover the more, what we consider the more significant and important one. Michael?
Yeah, I just on the subject of growing our channel, I just wanted to say to people, if you see a post on Facebook or Twitter about Space Oddities, please share that post, because the more people that share it, the more people will see it, and hopefully spread the word about us.
Yes, and looking at our viewing figures, we're pleased to report that we're moving in the right direction. But we'd like to do it a little faster to get there. Yeah. So if you could help us out by just sharing anything you see about us on Facebook or other social media. We've recently established a presence on Twitter, which we'll be using in the near future.
Twitter not.
Twitter not. No.
Yeah, and even share it on other social media platforms.
Yeah, absolutely. Any help you could give us, just getting the word about, would be gratefully appreciated. And we do appreciate you viewers, we really do. Thank you for staying with us this long this evening. I hope you've enjoyed our first anniversary programme. And we'll be back at the same time next week, of course, 8 o'clock UK time, 3 p.m. EST, with another dose of the universe for you. So until then, it's goodbye from me, and it's goodbye from him. And all those,
and him, and her,
and him,
gentlemen, Mrs. Barbara Dixon.
So until next week, have a fantastic week, everybody. Thank you for your support, and we'll look forward to speaking to you again next week. All the best. Bye.